Figure 2 shows the vertical cross-section for the center of a wax candle, and in the model the candle's formed by rotating this region around the y-axis. The point B has coordinate 3, 0, and C 5, 15. Units in centimeters, the curve BC is then represented by this equation between x equals 3 and x equals 5, where a is a constant. So determine the value of a according to the model. So we need to just substitute the point in here, one of the points that we have, to try and find out a. If you sub in 3, 0, you'll actually get the this equaling 0, so it's not going to be much use. It's all about the 5, 15. Therefore, I can say that 15 is equal to the square root of 225 times 5 squared minus 2025. That gives 3,600 over a. And a will be 3,600 square rooted divided by 15. This is 4. So we're also told that the curve CD is represented by this quadratic, and it also gives us the point D from that, because when x is 0, we're going to get y is 16. So 0, 16. And we're asked to use integration to determine, according to the model, the exact value of wax which should be used to make the candle. So this is a slight variation of a normal question because we have two different curves that we need to integrate. So what I'm going to do is integrate from 0 to 15, the first curve, and then 15 to 16, the second curve. This will give us the full volume of revolution. So I'll call the first one V1 and the second one V2. So V1, right, it's going to be the integral from 0 to 15 of x squared, pi x squared rather, with respect to y. This is me making a little cylinder here, essentially working out my value of x, but then turning it into this cylinder. That's my x squared times dy times by pi as well, because it's a circle and it's got a small little height. So I need to rearrange this to make x squared the subject. And that is going to become, well, remember a is 4, so I'll get 4y equal to the square root. Then I can square it, so I'll get 16y squared equals 225 x squared minus 2025. So then I need to add on the 2025 and divide by 225. That will get me my volume. I can actually take that 225 outside the integral and then let's integrate. We're going to get 16y cubed over 3 plus 2025y evaluated between 15 and 0. When I put in 0, I'm not going to get anything, so it's all about the 15. So 16 times 15 cubed divided by 3 plus 2025 times 15, 48375. Which gives 215 pi. I would say in this sort of question, especially for 9 marks, it's expecting detailed reasoning, so show the integral in full, but do also just perform the integral numerically. Okay, we have to use x on our calculator, but it's absolutely fine. Remember, I've got the pi in there as well. I just times by at the end. And we get 215, so we know that's correct. This leaves us with V2, which now we're integrating between 15 and 16. And it's this second curve, y equals 16 minus 0.04 x squared. Now I still am integrating x squared with respect to y to get these little cylinders. But now I need to make x squared the subject, so I'll get 0.04 x squared is equal to 16 minus y. And that actually ends up becoming, if we divide by 0.04, x squared equals 400 minus 25y. So that's what I'm going to put in. So pi times 400y minus 25 over 2 y squared, evaluated between 16 and 15. Okay, two limits to consider this time. So on one go, so 3,200 minus 3187.5 gives us 25 over 2. I'll leave it as a fraction. 25 pi over 2. And therefore total volume is just the sum, which ends up being 455 over 2 pi. They asked us to leave it the exact, so I'll just leave it in terms of pi, personally. I should also say, like, do work out this integral numerically as well, you'll get the same answer. Okay, and then we're asked to state a limitation of the model. So I wrote down that the candle may not be rotationally symmetric. That's the assumption we've made. Just like we can take this cross section and rotate it, i.e. we're going to get a prism. Some other options are that you could say the equation of the curve may not be suitable. The sides may not be perfectly smooth. It might be jagged or something, and there will be a hole in the middle for the wick. So there's some, and there'd be other possibilities as well. They're not restricted to that, but these all sound good. And then finally, we're told that when the candle was manufactured, 700 centimeters cubed of wax were required. Use this information and your answer to B to evaluate the model. So we got 455 over 2 times pi, which is actually 714.7. So this is part D. 714.7 is approximately 700, or they're close together, and therefore model is reliable.